Hello and welcome. This is lecture 3 for chemistry in the community. We're going to be talking about metric units. So go ahead, get out your notes, put lecture 3 at the top, put today's date at the top. Let's get started. So in chemistry class, we have to measure a lot of different properties of whatever chemicals we're doing an experiment on so that we can tell how those chemicals are changing. Again, chemistry is really the study of change. But how do we know if something's changing if we don't measure it? So the basic units that I want you to know are gram, which is a measurement of weight, and the gram is based off of water. It's supposed to be that 1 liter of water weighs exactly 1,000 grams. So, well, what is a liter? How is that defined? Because if we can't define what a liter is, then we can't define a gram. Well, a liter, that's how we're going to measure volume. And a liter is the amount of water in a 10 centimeter by 10 centimeter by 10 centimeter cube. So maybe we can draw that. Oh, there's a really bad cube. All of the sides are 10 centimeters. And the amount of volume that creates is exactly a liter. So the liter is based off of a length. How do we measure lengths? Well, centimeters, the base of that is the meter, which is how we measure length. Now, this one has been defined in a lot of different ways. The very first way the meter was defined it was supposed to be the distance from the equator to the North Pole was 10 million meters. This proved somewhat hard to standardize, knowing exactly where the equator was, exactly where the North Pole was. So the meter was redefined in a lot of different ways. It always kept the same length, but how we knew exactly what 1 meter was defined in a lot of different ways, including for some period of time, if you wanted to know how far a meter was, you had to travel to a location, I believe it was in Paris, where they kept the official 1 meter yardstick that all other meters were based off of. And nowadays it's based off of the speed of light, which we know is constant. And the last unit of measure we're going to use a lot is Celsius, which we'll use to measure temperature. And Celsius is based off of the idea that water freezes at 0 degrees Celsius and boils at 100 degrees Celsius, and then is divvied up evenly within that interval. So we'll be using Celsius whenever we measure temperature. So along with metric units, you often see prefixes. So I'm going to drop a question in here for you to think about prefixes just in the English language and how they help us. Okay, so how do they help us when measuring things in science? It helps us with really big and really small things. So really big and really small. So say I want to weigh something like a car. Here, I'm going to draw a really bad car. I want to put that on a scale. Well, if this scale reads things in grams, this is going to have a lot of digits. And when numbers have a lot of digits, it becomes very difficult to tell how big that number actually is. You have to actually count the digits. So if I'm weighing something like a car, I would probably want to start rounding up to kilograms. This could be something like 5,000 kilograms, where that K stands for kilo. And it saves me from having to write 3 more zeros. And when you have that many zeros, it's sort of hard to tell the difference between 50 million and 5 million. So 5,000 kilograms, which I think would still be pretty light for a car. I'm not entirely sure how heavy cars are, but what if I wanted to weigh something really small? Like maybe like a bacteria. So here's our bacteria. Well, if I was weighing this in grams, then I would have a 0.00000, a lot of zeros before I get any numbers that really mean anything. And so again, to save us from having to write all of those zeros, we use a prefix. This might be 5 nanograms. Again, I don't really know if that is what a bacteria weighs. I don't know how much a bacteria weighs, but it's probably somewhere near this. It isn't anywhere close to a gram, because a gram is about the weight of a small coin, like a dime. A dime is even a little bit heavier than a gram, but if we're dealing with bacteria, it's going to be way smaller than that. So we need to go down to prefixes like nano to show that this is really small. But both of these, the car and the bacteria, are both being weighed using grams. So here are our most common prefixes that I want you to know. So for something that's 1,000 times bigger than our base unit, we're going to use kilo, which is abbreviated K. Now for something that's 1/10 as big, that is deci, which gets a little d. 100th is going to be centi, which gets a little c. 1,000th, this is where we get the prefix milli from, which gets a lowercase m. And then these ones are a little bit less common, but a millionth is a micro, which gets this Greek symbol mu. And then a billionth is nano, it's an M, nano, which gets a little n. All right, and I want to show you how I would do a unit conversion if I wanted to convert my prefixes. Here we're going to go from milli back to just our base unit, and we're converting milligrams to just regular grams, but this is how we would do any conversion: millimeters to meters, milliseconds to seconds, anything. So what I'm going to do is I'm going to start by rewriting with my starting number, and then I'm going to treat it like a fraction, but I make one long fraction line, which kind of makes a table. And then the next things I put into this table are what I'm multiplying by. Well, I know I want to get rid of milligrams, so I know milligrams has to go on the bottom here, so that'll cancel out. And I want to get to grams, so I'll put grams on the top here. Now what I fill into these two boxes just has to be a true conversion ratio. So I know 1,000 milligrams are in 1 gram. Now, milligrams will cancel out, and then I just multiply this like a fraction. Multiply straight across the top, straight across the bottom. I end up dividing by 1,000. And when I divide by 1,000, my decimal point moves 3 units to the left. So I get 0, 0.03652 grams. The decimal point was there and it moved 1, 2, 3. But setting it up like this is nice because then you know for sure which way it's going to move. And you can actually do this calculation if you want in your calculator. You can do 36.52 divided by 1,000 and see that this is the number you get. And there's its unit of grams. All right, we'll call that good for this lecture video. I'll embed a few more questions here. But other than that, have a good rest of your day.